So we're going to graph quadratic functions that are in standard form. So standard form is a typical way that you've been seeing quadratics. Y equals ax squared plus bx plus c. And remember, a, b, and c are all some number. So an example would be y equals 2x squared minus 5x plus 8. So the question is, what does this graph look like? You know from your previous assignment that this 2 in front of the x squared is going to change how wide or narrow the graph is. So this one will be narrow because of the 2. And you know that the plus 8 over here is going to move the graph up or down. The new feature that we have here is the middle, the b term, the -5. So there's not like a simple way of saying, oh, it just moves like left or right, but it does kind of shift it to the sides and such. So what this lesson is about is how to graph this entire quadratic. So you could do the old school way of graphing like you did on your last assignment, and you could make a table of values, x, y, and you could put values in for x and find the corresponding y that goes with it, but that could take some time. And also, how do you know what part of the graph you're looking at? Because remember, a quadratic looks like a U. So what happens if your table of values only give you points on this side? Then you have to make your table even longer so that you can get points on the other side. So how I'm going to teach you to do this is to find points on both sides as a guarantee without having to do a ton of work. So, whenever you were learning quadratic graphs to begin with, we talked about some key features. One of them was the vertex. The vertex is either the highest point or the lowest point on the graph. In this particular example, it's the lowest point. So, to find the vertex when you're given an equation in standard form, you can find the x value of that coordinate by the formula x equals -b divided by 2a. And remember, b and a are the values in your equation. So in this example here, b is -5 and a is 2. You'd substitute those values into this expression or formula to get the x value. Now how do you get the y that goes with it? Well, whatever you get for x, you substitute it into your equation for x and you'll find the y that goes with it. The other feature you learned about was the axis of symmetry. And remember, the axis of symmetry always goes through the vertex. So the axis of symmetry is also x equals -b over 2a. These are the same. So once you know where your axis of symmetry is, then you're going to find a point on one side of the graph, or of that axis of symmetry. It doesn't matter if it's the left or the right. I typically choose the right side. So you'll have to do a little table, x, y, with only one point. And so I'd pick like x equals 2, and then I'd put 2 in for x and find the y that goes with it. A new item that you'll find is the y-intercept. The y-intercept is actually whatever c is. C is your y-intercept. So in this particular case, 8 would be the y-intercept. So I would know where it would be graphed. Now, once you have these items, there's only one thing left to do. However far from the axis of symmetry this point is that you found using the table, because this axis of symmetry is like a mirror, there's an identical point the same distance away. So now I'm finding a point on both sides, but I only have to do the math once, and then I can make my curve. So we're going to go through 3 examples of these steps. I have a graphic organizer here for you to help you with each of the steps. So we have our equation, y equals x squared minus 8x plus 1. The first step is you always want to identify what a, b, and c are. Because if we have those mixed up, then all of our steps are going to be wrong. So a is 1, b is negative 8, and c is positive 1. Now that we have all of those, we can go through our steps. So the first one says, find the axis of symmetry by substituting values into x equals negative b over 2a. So we have x equals negative b. b was negative 8. Let's change the size of this pen. Okay, so x equals, we have negative 8 all over 2 times a, which is 1. Negative makes a positive. 2 times 1 is 2. So we get x equals 4. 8 divided by 2 is 4. So we know that the axis of symmetry is at x equals 4. So we can go ahead and graph that if we want, or we can go through all of our steps and then graph. So let's go through our steps. So it says find the vertex by substituting the value of x in the axis of symmetry into the equation to get y. So y equals x squared, x is 4, minus 8 times 4 plus 1. So 4 squared is 16, minus 8 times 4 is 32, plus 1. 16 minus 32 is negative 16, plus 1 gives us negative 15. So the coordinate here is 4, negative 15. Find the point that contains the y-intercept by identifying c in the equation. c is 1, so our y-intercept is 0, 1. Remember, when it's a y-intercept, we're on the x-axis, or on the y-axis, on the y-axis, so x is always 0. Now it says find 2 or more points. So this is where you actually create a table of values. Now, what I think is the best option is to go ahead and graph the information you have so that you are strategically using x values or identifying x values to use. So draw our x-axis and our y-axis. Okay, our axis of symmetry is at 4. 1, 2, 3, 4. So I just do a dotted line to know that's my axis of symmetry. Our vertex is at 4, negative 15. So I need to count negative 15. Perfect fit. And our y-intercept is 0, 1. All right, so when I'm choosing some x values here, I'm going to choose them to be on the same side of the axis of symmetry. So I'm going to use some simple numbers and just do 1 and 2. So we go back to our original function, and we're going to substitute 1 for x to get the y value, and we're going to substitute 2. So when we do 1, we have 1 squared minus 8 times 1 is 8 plus 1. So 1 minus 8 plus 1. So negative 7 plus 1. So we have negative 6. So we have 1, negative 6. Now we're going to do 2. So we have 2 squared minus 8 times 2 is 16 plus 1. 4 minus 16 plus 1. Negative 12 plus 1 is negative 11. There we go. So now we've graphed these parts. Now it says to reflect. Reflect the points across the axis of symmetry and connect a smooth curve. So this is what I was talking about. How far this y-intercept is from that axis of symmetry, there's an identical point on the other side. So it's 1, 2, 3, 4 away. So go 1, 2, 3, 4 away, and there's a point. Here we're going 3 away, or 2 away, 1, 2, 3, and we go 2 away, And now we can connect a smooth curve to create our parabola. Now, the last part is domain and range. I don't have it listed as a step, but it is part of your assignment. So the domain of a quadratic, remember, the domain is negative infinity to positive infinity. The range depends on if it's a maximum point or a minimum point. This graph has a minimum point, and remember, that's at negative 15. So y is greater than or equal to negative 15. So I have two more examples. All that's changing are the values that we're using. So here, a is negative 2, b is 1, and c is negative 3. So you're just going to go through the exact same steps in order to graph it. Now, notice that a is a negative value. You learned through your previous assignment that when a is negative, your graph should be going down. So a positive a means it's a smile, it's a happy face. But a negative a means it's going down, it's a frown face. So whenever I graph it, I know what my graph should look like. That will help me check that I am finding the correct parts. So our axis of symmetry, negative b over 2a. So negative 1 over 2 times negative 2. It's because it's a positive 1/4. So it's a fraction. And you're just going to sketch it. It's okay, that's not perfect. The vertex. So when we substitute 1/4 into our equation, what do we get for y? You might want to use a calculator for that. C, well, C is negative 3. Then you're finding 2 more points. You're going to graph them and reflect them, same as before. So let's look at one more. This equation looks slightly different. There's no x term, so you could rewrite this as negative x squared plus 0x minus 6. And now you can identify a, b, and c. A is negative 1, b is 0, and c is negative 6. Again, the process is the same. So everything we've done for this first example, you're just repeating. The difference are the numbers that you're using.